Okay, solution for question number 4. So question number 4 is from chapter 9, simple harmonic motion. We have a graph of displacement against time, or you can write down it as x. Okay, so we have the question is the figure shows a displacement versus time graph of a body that oscillates in simple harmonic motion at an angular speed of 2 radian per second. Okay, so we have our omega here. Sketch and label the graph of velocity against time. So class, if you refer this graph, we can see that this graph is having sine function. So we can have a general equation, x is equal to a sine omega t, and this is because it starts from 0. So to get the velocity, we want to plot the graph of velocity against time. So we have to know the equation for velocity. So velocity is equal to differentiate displacement over time, or differentiate y. Okay, differentiate a sine omega t with respect to t. Finally, you'll get v is equal to a omega cos omega t. Okay, so now we can plot our graph of velocity against time. So make sure you write down the symbol and unit. Okay, so this is cos function, so it's going to be this form, and your amplitude of the graph is going to be a omega. So a omega is equal to, okay, we can calculate a omega here is equal to 3 times 2, so it is equal to 6. So here is 6, and you can label your graph as here is negative 6. Okay, so that's the first graph. To answer B, okay, so question asks us to plot A against time. So we'll do once again the differentiation. So A is equal to differentiate V against T. Okay, so differentiate A omega cos omega T with respect to time. Differentiate cos will get negative, so negative sine A omega squared sine omega T. Okay, so your graph of acceleration against time is going to be acceleration, the unit is meter per second squared. Okay, is going to be negative sign. So you have to flip your sine graph. Okay, negative sign, and you have to label the amplitude. So this time your amplitude is going to be a omega squared. It is equal to 3 times 2 squared, so it's 12. Okay, so now you can label 12 here and also negative 12 below. So this is your graph for V against T and also VA against T.